All right, this lecture is on heat transfer. Harry Truman said, if you can't stand the heat, get out of the kitchen. So the goals for this presentation is to, number one, understand how and why heat is transferred. And then number two, you need to be able to distinguish between the three methods of heat transfer that are conduction, convection, and radiation for any given situation. So number one, we say that two objects at different temperatures will always seek to equilibrate their temperatures. In other words, if you have something that's 100 degrees Fahrenheit and something that's 50 degrees Fahrenheit, they will mix their temperatures until they have the same temperature somewhere in the middle. Heat will always flow from the higher temperature to the lower temperature. There's no such thing as cold. Something doesn't make an object colder. What it does is it removes the heat. And one of the first people to actually study the relationship was James Joule, pictured here. And he actually has the unit of energy, the joule, named after him. Remember that heat flows due to molecular collisions. Okay, just keep that in the back of your mind as we go through the various methods of heat transfer. The first one is conduction. Conduction is the transfer of heat by direct contact. The key is that it requires direct contact. And so what you see here is you actually see a brand being put on a cow. And so this is very, very, very hot. And what it does is it transfers the heat to the skin by direct contact. If you were to hold this kind of close to the skin but away from it, you would feel some of the heat, but not nearly as much because it lacks direct contact. So you can have contact with the air molecules, but the problem is that there are very few air molecules compared to the direct contact. The more surface area, the more contact between atoms, the more heat is going to be conducted. So in order to have a clean amount, a large amount of heat conducted, you have to have something that is actually in direct contact, not via the air or anything along those lines. Now, conductors also have insulators. Okay, an insulator is something that will slow down the conduction of heat by preventing direct contact. And the most obvious example that you have is you actually have insulation in your house. Now, this insulation in your house right here, what it does is it's got air pockets that are in it that are designed to prevent heat from going from one end to the other. Also, insulators tend to have they can tend to absorb a lot of heat for each one molecule that they have. They have what's called a high specific heat, and we'll talk about that. You also generally have, sometimes with windows, what you have is you have a layer, and then you have a gap, and then you have another layer. Sometimes they're called dual pane or triple pane windows. And that also acts as an insulation barrier. Heat is not transferred easily between those particular panes because there's nothing in between. It prevents the heat transfer by conduction. Convection is the second method of heat transfer, and what it is, it can only happen in a fluid. Now, a fluid consists of both gas and liquid, but what happens is something that's warm will expand, and since it expands, it will rise, and then something that's cold gets more dense and then will fall. So that's what creates wind and ocean currents. It's also why if you take a flame and you put your hand above a flame, it's a lot hotter than if you were to put it to the side of a flame. Because what's happening is all that air that's heating up is rising, and that air that's hot hits your hand, or as opposed to if you put it to the side, it's not nearly as bad. One key thing is that convection can only occur in the fluids. It cannot occur in a solid. Now, the reason why it can is because if you have something that's solid, it can't rise to the top of the solid and then fall to the bottom because the molecules are stuck where they are. So convection can only occur in a fluid. Next, we have radiation. Radiation is kind of the catch-all. If it's not conduction, if it's not convection, it's radiation. All energy from the sun comes via radiation, and here's the reason. Radiation is the transfer of heat that does not involve matter. Okay? So there is no matter in between the sun and the earth to speak of. So what we have is we have a vacuum in space. So there's nothing that's in between that can transfer via conduction or convection. Since there's no matter, it has to be radiation. So radiation is the matterless transfer of heat. Sometimes it's called radiant energy, but it's kind of the catch-all. If it's not conduction, if it's not convection, it's radiation. Now, you should know learn, memorize, recall all of the information above. You should understand how and why heat is transferred, and you should be able to distinguish between conduction, convection, and radiation. And more specifically, if you're thinking about it, you should be able to show in your house methods that you can have to prevent, or excuse me, to have heat loss via conduction, convection, and radiation in your house.